Seat A12 appears available on 2 phones. Maya taps hold. Leo taps it 1 heartbeat later. Both requests read available. Both services write reserved. Both payments succeed. Now 2 confirmation emails point to 1 chair. The system is fast, distributed, and wrong. We will prevent that failure with 1 rule. A seat can belong to only 1 unexpired hold, or 1 confirmed booking, never 2 of either. Then we will follow the harder case. Payment succeeds, but its response disappears. This FastPrep exercise is based on reported Amazon on-site interview evidence, last seen July 27, 2026. It is illustrative interview practice, not a description of Amazon's production architecture. The product lets users discover events, view assigned seats, reserve 1 or more seats briefly, and pay for a confirmed booking. The public exercise assumes 10 million monthly active users, 50,000 active events, and as many as 10,000 seat requests per second during a popular on-sale. Unpaid reservations expire after 5 minutes. In this illustrative design, search results and cached seat maps may be slightly stale. That is acceptable for discovery. They are not allowed to decide who owns A12. Only the authoritative inventory path may change ownership. So split the architecture early. A read path scales event search and seat map browsing. A smaller correctness path owns holds, bookings, and payment outcomes. Model each seat as a tiny state machine. Available may become held. Held may become sold for its current owner, or return to available after 5 minutes. For this walkthrough, sold is final. Every hold records a hold ID, an owner, an expiration time, and a version. The invariant is visible in the durable record. A12 has 1 authoritative state and at most 1 current owner. A hold is not a sale. It is a short lease on the right to finish checkout. That distinction lets the system free abandoned inventory without weakening the final booking guarantee. Maya's client sends the event, the requested seats, and an idempotency key. The booking service does not trust the availability cache. It asks the inventory authority to change A12 from available to held, but only if that condition is still true. The comparison and the write must be 1 atomic operation. For this walkthrough, make a group hold all or nothing. Either every requested seat changes state in 1 transaction, or none does. Maya's transition wins first. A12 is held by her request until the recorded deadline. Leo reaches the same gate, but available is no longer true. He receives a conflict and refreshes the seat map. The database transition prevented the double booking, not a faster cache, not a lock living inside 1 application server, not lucky timing. If Maya retries because her response vanished, the idempotency key returns the same hold instead of creating another one. A 5-minute hold creates breathing room for checkout, but it also removes inventory from everyone else. Expiration belongs in the seat record, not only in an in-memory timer. A cleanup worker may release expired holds, but every release is guarded. Change held to available only if the hold ID and version still match and the deadline has passed. If a late worker encounters a newer hold or a sold seat, it does nothing. Without that check, an old timer could wake up late and release a seat that has already been paid for. The timestamp says when a hold is eligible to expire. The conditional transition makes the expiration safe. Now Maya pays while her hold is active. Before contacting the payment provider, the booking service creates 1 durable payment attempt tied to the hold, and a stable payment key. If payment is declined, the hold may be released or allowed to expire. If payment is approved in time, 1 local transaction changes A12 from held by Maya to sold to Maya, and creates the unique confirmed booking. The harder case is an approved payment whose response times out. A timeout does not mean failure. Starting a fresh payment could charge Maya twice, so the attempt becomes pending, not failed. A callback or a recovery worker can resolve the same durable attempt. Duplicate outcomes are harmless because every path uses the same payment identity and the same guarded held to sold transition. If that transition already committed but its response vanished, Maya's retry returns the existing booking. If approval arrives after her hold expired and the seat belongs elsewhere, correctness wins. Do not steal the seat back. Record the failed conversion and void or refund the payment as appropriate. The full design has two paths: search indexes and caches scale discovery. The booking service and authoritative inventory store protect ownership. Partition by event to spread ordinary load, while every seat keeps one logical write authority. A popular on-sale is skewed traffic. An admission queue and per-event limits protect the write authority. Let clients wait before the gate, instead of overwhelming it and increasing conflicts. The cost is deliberate. A hot event may queue or return conflict. We accept that pressure because relaxing the invariant would create two legitimate buyers for one physical chair. Remember one line through the system. Discovery can be fast and approximate. Ownership must be exact. One atomic transition moves A12 from available to a 5-minute hold. A matching payment outcome moves that same hold to sold. Retries repeat the existing result, and late workers cannot overwrite a newer version. During an inventory authority failure, the system may return conflict or pending instead of accepting more bookings. That sacrifices some availability to preserve the promise users care about most. One seat, one active hold, one final booking. That is how two buyers can race for A12, and only one leaves with the ticket. Practice the complete Amazon ticket booking interview exercise on FastPrep.